Hello guys, so welcome back to this channel. In this video I'll be solving the full calculation. I'll be solving the full calculation question on electric field. Okay, so I'll be solving the full calculation on electric field. Okay, so now let's start with the very first question. Okay, so in the very first question I said an electron of charge 1.6 times 10 raised to the power minus 19 coulomb is situated in a uniform electric field of intensity or field strength 120,000 volts per meter. Okay, so they said we should find the force on its acceleration and the time it takes to travel 20 millimeter from rest. They gave us the mass of our electron to be what? 9.1 times 10 raised to the power minus 31. Okay, so in most questions they might not give you the mass of an electron, so it's left for you to know the mass of an electron. The mass of an electron is 9.1 times 10 raised to the power minus 31 kg. Okay, now let me break down the question. Okay, so if you look at in the question, they're asking us to look for three things. Okay, the very first thing they're asking us to look for for force. Second thing they're asking us to look for is acceleration. The third thing they're asking us to look for what? Time. Okay, so if you look at the question, it said an electron of charge. This is the charge of the electron. Okay, yes, they said an electron is situated in an electric field. Okay, so they're asking us to calculate the force acting on the electron. They're also asking us to calculate for the acceleration with which the electron will move. Then the last thing they're asking us to calculate is the time it takes the electron to travel 20 millimeter from rest. Okay, so this question is very easy. Okay, so what are we going to do? Let's look for force first. Okay, so what is the formula of electric field intensity or electric field? Remember, I gave you guys in our previous class, I told you guys that there are different formulas, right? So electric field intensity is usually equals to what? Force over charge. Okay, is usually equals to force over charge. Now in the question, they gave us the electric field in the question, which is E, is what? 120 volts per meter. Okay, now this volts per meter is also the SI unit of electric field intensity. Okay, remember the SI unit of electric field intensity is what? Newton per coulomb, right? Yes. Now electric field also has another SI unit, which is what? Volts per meter, or you can say, so it's the same thing. Okay, so in our next class I'll tell you guys where electric field intensity has volt per meter as SI unit. Okay, yes, this is the SI unit. Okay, this also is the SI unit, it's the same thing. Okay, now next class I'll tell you guys where. Okay, so in the question they gave us the electric field to be what? 120,000 volts per meter, right? So electric field is 120,000, right? Yes. What are they asking us to look for? They're asking us to look for what? The force acting on the electron, right? Which you don't know. Then what about the charge of the electron? The charge of the electron is what? Is 1.6 times 10 raised to the power minus 19, right? Yes, what I'm going to do is very easy, just cross multiply. Therefore, F, which is the force, will be equals to what? 120,000 times 1.6 times 10 raised to the power minus 19. So if we do it, if we calculate it, our answer will be what? Okay, so 120,000 times 1.6 times 10, 1.6 times 10 raised to the power minus 19 give us 1.92 times 10 raised to the power minus 14. Okay, so that is the force acting on the electron. The force acting on the electron is equals to what? Is equals to 1.92 times 10 raised to the power minus 14 Newton. Okay, so this is the force. Now, what is the next thing that's supposed to look for? The electron, right? Yes, so it's very easy. We have gotten our force. Now, that's not to look for the acceleration, right? Yes, that's not to look for the acceleration of the with which the electron moves, right? Yes, so which is very easy. This is our force. We have gotten the force. This is the force, right? So how are we going to get the acceleration? It's very easy. Acceleration, we all know that force. What is the formula for force? Force is equals to what? Ma. Now you may ask, why am I using this formula? This is because we have gotten the force already. We know the mass of electron, right? Yes, so we can easily use this formula to get towards the acceleration of what? Electron, right? Yes, so it's very easy. So the force acting on the electron is what? Is 1.92 times 10 raised by what? Minus 14, right? Yes. So it's equals to, now the mass of electron is what? Is what? 9.1, right? 9.1 times 10 raised by minus 31, right? Then times what? Acceleration, which we don't know. So what I'm going to do next, we divide both sides. I want to make A stand alone. Divide both sides by what? 9.1 times 10 raised by what? Minus 31, right? 9.1 times 10 raised by minus 31. This one will cancel this. So therefore, our acceleration will be equal to what? Now, if we do it, these two, yeah, if we cancel them, let's do it. Okay, so let's do it. So minus 14, okay, minus 31 will give us 17. Okay, so there's a reason why we give everything here will be okay. Now let me just tell you guys something. Now if we use calculator to do it, we have different values. Let's see. Let's divide it. 1.92 times 10 raised power minus 14 divided by 9.1 times 10 raised to power minus 31. Now, okay, I'm coming. All right, so it gave me the right value today. Okay, so let's do it. It gave me the right value. Now let's continue. So if we divide it, to give us let me do it again. Let me do it again. So it give us okay 1.92 times 10 raised to power minus 14. Okay, minus 14 divided by 9.1 times 10 raised to power minus 31. So our answer, I'm coming. Let me change it to this thing. Okay. So our answer here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, 15, 16, 17. So our answer here is 2.1 times 10 raised power 17. Okay, let me count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, so our answer here will be, I think it's 16. Okay, so 16. So our answer here is 2.1, okay? Our answer is 2.11 times 10 raised by what? 16 meter per second square. So this is the acceleration with which the electron moves. Now, what next are we going to look for? I'm going to look for the time. I want to look for the time with which the time it takes the electron to travel what 20 millimeter from rest. So we have gotten our acceleration to be 2.11 times 10 to the power 16. Then this is the force, right? So the force is what? The force is 1.92 times 10 to the power minus 14. Then the acceleration is what? 2.11 times 10 raised power what? 16, right? So we are gotten our force, we have gotten our acceleration. Now what next? We want to get the time, okay? We want to get the time with which it travels 20 millimeter. Okay, remember to the distance is 20 millimeter. So we need to convert this to what? To meter. Now before then, which formula are we going to use to calculate what the time it takes the electron to travel 20 millimeter? It's very easy. We use equation of motion, okay? The equation of motion we're going to use is S equals to what? Ut plus half AT square. Okay, so we are looking for what? The time, right? Yes. But let's continue. This S is our distance. So distance is what? 20 millimeter. Remember, we need to convert this 20 millimeter to what? To meter. How are we going to do it? Divide by what? 1000. Okay, so if we divide by 1000, 20 divided 1000 give us 0.02. Give us 0.02 meter, right? Therefore, the distance is what? 0.02 meter, right? Is equals to, now where is the initial velocity? Now since the electron starts from rest, then the initial velocity is what? 0. Then times, you are looking for time, right? Then plus half. Our acceleration is what? Acceleration is 2.11 times 10 to the power 16, right? Then times time, right? This square, that is what we are looking for, right? 0 times 2 give us 0, right? So 0.02, everything here will be 0, right? So then half times 2.11 times 10 to the power 16 t square, right? So if t square multiply this to give us 2.11 times 10 to the power 16 t square, right? Now half times 2.11 times 10 to the power 16. So let's do it. Half is still something as 0.5. So you can say 0.5 times 2.11 times 10 raised to the power of 16. So what we got here is Okay, what we got here is 1.055 times 10 raised to power 16 t square. Now what are we looking for? We're looking for t. We divide both sides by what? This value, right? To free t. So 1.055 times 10 raised to power 16. So divide both sides by 1.055 times 10 raised to power 16. Right? This one will cancel this. Therefore, t square will be equals to what? 0.02 divided by what? 1.055 times 10 to the power 16. Right? Yes. Okay, since we are looking for, we are not done yet. So since we are looking for t, and this we are looking for t, we need to what? To remove this, we need to remove the square by taking the square root of both sides, right? So if we take the square root of both sides, this square will cancel the square root, right? So t will be equals to, now let's divide the value. We can use calculator to just do it straight. If you use calculator to do it straight, let's use calculator to do it straight. So the square root of 0.02 divided by 1.055 times 10 raised to the power of 16. So if we do it, we get we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we have 1.38 times 10 to the minus 9. Okay, so if we do it, let me count again. Okay, so if we do it, we have 1.30 1.38, or we can say 1.4 times 10 raised to the minus 9. So the time is what? 1.4 times 10 raised to the minus 9 times 10 raised to the minus 9 seconds. So this is the time. Okay, yes. If you don't want to do it this way, just divide the values first. If you divide the 2 first, then you take the square root. So if you divide the 2, 0.02 divide 1.055 times 10 raised to the power of 16. Then you, after getting the value, then you take the square root of the value. You get this. Okay, so this is the answer. Now let's move to the next question. In the next question, question 2a, they said, what are the magnitude and direction of the electric field 2 centimeters from a fixed point of from a fixed point charge of 3 times 10 to the minus 10 coulombs. So what are we looking for in this question? Okay, so they're asking, we're looking for what? Electric field, right? Now, which formula we are going to use? Remember, in our previous class, I gave you guys different formulas for electric field. Electric field is equals to force over charge, right? Also, electric field is still equals to um, K times charge divided by what? R square, right? Yes. So these are another formula for electric field. There are different formulas as well. Remember, now you can just go and watch our previous class. You will see it for yourself, okay? So there's still other formula. Remember, K is what? You know that K is the same as 1.4, 1/4 pi E naught, right? So in the place of K, I can put this value here. We now have another formula, which is E is equals to charge over what? 4 pi E naught R square. So this is another formula for what? This is another formula for electric field intensity, okay? So you can use any of this formula depending on the type of question you are giving. Okay, now don't forget that in our previous class I told you guys that K is equals to what? 9 times 10 raised to the power 9, right? Yes, this is the value of K. Okay, yes. So you can use any of this formula depending on the type of question you are using that you are asked to solve. Okay, now you can use this very first one when they ask you to look for when the quantities in the questions is relating to force, charge, and electric field. Okay, why this one? You can use this formula when you are dealing with electric field, distance, and what? Charge. We can use this one. Yeah, we can still use. Yeah, we can use this other one for the same questions. Okay, because they are two at the same thing. Okay, so now let's continue. Let's continue this question. Okay, now in this question, they're asking to look for what? They're asking to look for. They're asking to consider the magnitude of what? They're asking to look for electric field. Okay, look at the question very well. They give us distance and give us charge. Did they give us force? No. Therefore, we are not going to use this first formula. The formula we're going to use is this one. Okay, which is very easy. So we are looking for what? Charge. And we are looking for electric field, right? So we know that K is what? K is 9 times 10 raised to the power 9, right? Then times the charge is what? 3 times 10 raised to the minus 10, right? So 3 times 10 raised to the power minus 10. Then divided by what? The distance. The distance is what? 2 centimeter, right? Now, since it is in since this distance is in centimeter, we need to convert it to what? To meter. How we going to do it? By dividing by what? 100, right? So if we divide it by 100, if we divide 2 divide 100 will give us 0.02, right? It will give us 0.02. Therefore, the distance is what? Is 0.02 meter. Remember, this distance carries square, right? Yes. So if we do everything, let's just do it straight, okay? So let's just do it straight. How do you just solve it straight, okay, to save time? Okay, so we do it straight. 9 times 10 raised power 9, then times 3 times 10 raised power minus 10, then divide by bracket open 0.02 all square. Now our answer is 6,750. Okay, so the electric field is what? Electric field is what? 6,750 Newton per coulomb. Okay, yes. So that is the. Now remember, this question 2 is of 2 parts. This is a part A, this is a part B. Okay, so the electric field is what? Is 6,750. Now let's go to the next question, which is the part B. They said how far away from the point charge does the field drops to 20% of its original value? Okay, they said how far away from the point charge does the field drops 20% to 20% of its original value? Okay, now this question B is referring to question A. Okay, yes. Now let me explain. Now, generally, in our previous class, I told you guys that the charges are what produce electric field, right? And the field produced by a particular charge is not affected by that charge. Okay, the field produced by a charge acts on another charge. Okay, the field that produced by a charge does not affect the charge. Okay, now let's say, for example, let's say this is a source charge. Okay, this is source charge. Okay, then this is a point charge, right? Now, the source charge, okay, let me do something like this. Okay, so yeah, let's just continue like this. Okay, so this is a source charge, this is a point charge. Now, the source charge, yeah, the source charge exerts electric field on the electric field of this source charge. Okay, I'm coming. Source, right? Of this source charge, this one is point charge. Now the electric field of this source charge, let's say this is a positive charge now, for example. So the electric field of this source charge is acting on what? On this point charge, right? Yes. Now let's go past this first question. I said, what are the magnitude of the electric field 20 centimeter from the fixed point charge? Okay, now let's say the electric field that we calculated earlier, let's say this source charge is the electric field of this source charge acting on this point charge. Let's say the electric field is what? Is 6,750, right? Yes. And the distance between them initially was what? The distance between them, if we convert the distance was 2 centimeter. So if we convert it to meter, to what? 0.02 meter, right? Yes. So this was distance between them, according to the first question, right? Yes. So this source charge, the electric field of this source charge is acting on this point charge, right? And the electric field is what? 6,750 Newton per coulombs, right? The distance between these two charges is 0.02 meter, right? Yes. Now, question B is not telling that. In question B, I'm asking them, they said, how far away from the point charge does the field drop to 20% of its original value? Okay. Now, what are they telling us to do in this question? Now, they're telling us that if we are to take this point charge, let's say we take it farther away. Is that if we are to take this normally, we all know that this is the formula of electric field, right? Electric field is equals to KQ all over K times charge. Electric field is equals to K times charge divided by the square of the distance, right? Yes, divided by the square of the distance. Now, if you look at it very well, you find out the electric field is inversely proportional to what? It's inversely proportional to the square of the distance. So let's tell you that That is to tell you that the farther the distance, the lower the electric field, and also the higher the electric field, the lower what the distance. So what is it telling us? This is telling us that the closer the charges are together, the stronger the electric field acting on the charge. But the farther away the charges, the weaker the electric field, right? Yes. So in this question, they are telling us that they are telling us that in the question that they're asking us to look for the distance, okay? They're asking us to look for, they said, okay, if we are to take this point charge, we take it farther away at a particular distance. This electric field drop by 20%. Drop by 20%. At what distance will this point charge and will be moved further away? So that's not a distance at which this point charge will move further away for the electric field to drop by what? By 20%. Okay, so that is just it. Therefore, when I mean 20%, means that when I say 20%, means that so it means I'm coming. So it means that now normally where is the electric field initially? Where is the electric field acting on the point charge? Initially, we can call this electric field, we call it E1, which is 6,750, right? Yes. So this is the electric field acting on the point charge initially, right? Yes. Then what is the distance between them initially? The distance between them, which is R1, is equals to 0.02, right? Yes. Now, they said how far away we are looking for what? R2, we don't know. How far away from the point charge does the field drop to 20% of its original value? This is the original value of the field, right? So they are telling us that the field drop to 20% of its original value. So the original value is what? 6,750, right? Then times 20%. So that will be our E2. Okay, that would be our E2. What are we looking for? We're looking for what? R2. Okay. Now this 20%, 20% is still something as what? 20 divided 100, right? 20 divided 100. So if we multiply this, we will have the value of what? E2. Let's do it. So 6,750 times 100, then divide by, times 20. Okay, 6,750 times 20. Then divide by 100. So the E2 is 1,350. So therefore, E2 is what? Is 1,350. Okay. So we have got, we know our E1, we know our R1, we know E2. Then we are looking for what? R2. It's very easy. Okay. So which formula are we going to use? It's very easy. Remember, okay. Remember, we all know that electric field is equals to the constant K times charge divided by what? R square, right? Yes. Since we are dealing with the same charge, okay, now, since we are dealing with the same charge, okay, yeah, we are dealing with the same charge, okay, so let us continue, okay, so let us continue. Now, yeah, since we are dealing with the same charge, everything is constant, right? So we can just say that, okay, we can just make K and this charge constant, okay, yes. But let me just do it. You find out that it not affect our answer, but let's just do it, okay? So now if we cross multiply, if we are to cross multiply, we have something like this: E R square is equals to K Q, right? Yes, it's equals to K Q. Now we can just say, based on the fact that we are dealing with, in these two scenarios, we are dealing with two charge, we are dealing with two, we are dealing with two feed, we are dealing with two distance, and we are dealing with these two distance and the two feed is all about what? It's only about one particular charge, right? Therefore, we can make this charge, we can make it constant. We can just say, okay, we can make it one. It does not affect cannot affect our answer. Okay, so we can make everything here K. This K and this other one, we can make everything just K, which is constant. Okay, yes, we can make it constant. Don't worry, I will still solve it the normal method. If you still find out that it will not affect our answer. So E arrow square is equal to K. Now, since K is equal to E arrow square, therefore K is what? K is E arrow square, right? So we can call this one E1 arrow 1 arrows E1 arrow 1 square, then E2 arrow 2 square, right? Yeah. So we are looking for what? Arrow 2. So our E1 is what? 6,750. Then times our R1 is 0.02, then not square is equals to E2 is what? 1,350, then times R2. That's what we are looking for, right? So if we let's just so if let's multiply them. So 6,750 times the square of 0.02, okay, to give us 2.7, right? So give us 2.7 is equals to this, multiply this will give us 1,350 R2 square. What are we looking for? We're looking for R2. Divide both sides by what? 1,350. Okay, 1,350. So I'll cancel this. Therefore, 2.7 divide 2.7 divide 1,350. Well, it will give us 0.002. Okay, so R2 square is equals to 0.002. Okay, now what are we going to do next? We are looking for R2. So we need to remove this square. Right? We are taking the square root of both sides. So this square will cancel the square root. So let's take the square root of 0.02. Square root of 0.002 will give us 0.044. Okay, it give us to give us R is equals to 0.044. Okay, 0.044. Okay, yes. So meter. So this our answer is in what? Is in meter. Okay, 0.044. But if we have to make it in centimeter, we multiply by 100. Okay, if we want to make it in centimeter, we multiply by 100. Our answer will be 4 centimeter. Okay, so here is 0.044 meter. Okay, but if I have to convert it to I'm coming. Okay, let me do it again. So root 0.002. Okay, 0. So it will give us 0.044. Now if we have to convert it to centimeter, we multiply by 100. So our answer will be 4. Okay, 4.4 centimeter. Okay, so it's the same thing, 0.044 meter or 4.4 centimeter. So it's the same thing depending on which form your is in the your answer. Okay, if the answer is in centimeter, convert it to centimeter. If your answer is in meter, convert it to meter. So that is just it. Okay, yes. So the answer is 0.044 meter. Okay, so that is just it. Now, if we are to, okay, I told you guys earlier that we can still use this one straight. Okay, yes. If let's use that, let's use it straight, for example. Okay, so let's use it straight. Now, since we know that E is equals to KQ over R square, right? Yes. So now we still know we still know that E is equals to KQ. We can say okay, we can say this one is E1 R1, right? Then because one E2, then R2 square, right? Yes. Now if you look at it, if you cross multiply, we cross multiply, you find out that E1 R1 square is equal to K times the charge, right? So is E1 R1 square is equals to K times the charge. Then if we see cross multiply in this other side, you find out that E2 R2 square is equals to what? K times the charge, right? Look at it. Both of them equal this. Therefore, we can say since this one equal this, since this one equal this, therefore we can say E1 R1 square is equals to E2 R2 square. So that is it. So we can see we will see arrive in the same earlier. We will see arrive at this formula. So that is just it. Okay. So it's very easy. And let's move to the next question. Okay, the next question, which is question 3. They say what is the magnitude of a point charge whose electric field 50 centimeter away has a magnitude of 2 Newton per coulomb. So we are looking for, they say what is the magnitude of the point charge? We are looking for the charge. Okay, they give us distance, they give us electric field, we are looking for charge. So use the formula. E is equals to K times charge over what? R square. So this is the formula we're going to use. Okay, so it's very easy. Electric field is what? Is 2, right? We know K is what? 9 times 10 raised by 9, then times, we are looking for the charge, we don't know, then divide by what? The distance. Look at it. The distance is in centimeter. So we convert it to meter by dividing by what? 100. Right? So it's divided by 100 to be what? 0.5. So the distance is 0.5 meter. 0.5 meter, then all square. What are we looking for? We're looking for charge, right? So what are we going to do? First multiply. Therefore, to be 2 times the square of 0.5, then is equals to 9 times 10 raised by 9s, right? So if we multiply this, so will be our answer. Okay, so let's multiply it. So 2 times 2 times 0.5 square will give us 0.5. Wow. Give us 0.5. Then is equals to 9 times 10 raised by 9 s. So we're looking for s. Divide both sides by 9 times 10 raised by 9, right? 9 times 10 raised by 9. This one will cancel this. So 0.5 divide um so 0.5 divide 9 times 10 raised by 9 give us I'm coming. Okay, so let me do it. So 0.5 divided by 9 times 10 raised to power 9 give us 5.55 times 10 raised to power minus 11. Okay, so the charge is what? The charge is 5.555 times 10 raised by what? Times 10 raised by minus 11 coulomb. Okay, yes, times 10 raised by minus 11 coulomb. So that is just it. So that is the answer. Okay, now let's move to the next question, which is question 4. Okay, so now let's continue the last part of this calculation, which is question 4. Okay, so in question 4, they're asking us to calculate. Said question 4 is divided into two parts, part A and part B. So they said a neutral water molecule in its vapor state has an electric dipole moment 6.2 times 10 raised to power minus 30 coulomb meter. Okay, so this is electric dipole moment. Now they say how far apart are the molecules and the molecule centers of positive and negative charge. So what are we looking for here? We're looking for the distance. Now remember, electric dipole moment. Okay, so remember, electric dipole moment usually equals to this formula is equals to charge times distance. Okay, so they gave us electric dipole moment to be what? To be 6.2 times 10 raised by minus 30, right? Now, they're asking us to look for what? Distance. They say how far apart are the molecule centers of positive and negative charge. Now, positive and negative charge, we're talking about proton and neutron and electron, right? So this charge, right? We are looking for distance. So charge, since we are dealing with proton or electron, what is the charge of a proton or electron? Their charge is 1.6 times 10 to the 1 minus 19, right? Yes. So times what? Distance. We are looking for the distance. They said how far apart. We are looking for distance. What I'm going to do? We have both sides by 1.6 times 10 to the minus 19. Okay. So if we do it, so if we do it, so 6.2 times 10 raised to power minus 30 minus 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 30 divided by 1.6 times 10 raised to power minus 19. So the answer is, so the distance is which the answer is equals to 3.875 times 10 raised by minus 11. Okay, so this is the answer. Then the next B, they said if the molecules placed in an electric field of this electric, give us electric field. They said what maximum torque can the field exert on it? So it's very easy. So the maximum torque, this is the formula. The maximum torque usually equals to electric dipole moment times electric field. Okay, so times electric field. So we're looking for maximum torque, right? And what is the electric dipole moment? The electric dipole moment is 6.2 times 10 to the power minus 30. 10 times the electric field in the question is what? 1.5 times 10 to the power 4. So if we do it, if we multiply it directly, we get the maximum torque acting and the field can exert on it. So let's do it. So 6.2 times 10 raised to the power of minus 30, then times 1.5 times 10 raised to the power 4. So the answer is 9.3 times 10 raised to the power minus 26. So the torque is 9.3 times 10 raised to the power minus 26 Newton meter. So this is the maximum torque. So this is the end. So this is the end of the calculation on the this is the end of the full calculation on electric field.